Welcome to Physics with Mr. Brazil. Today we're going to be looking at a box on a horizontal plane with an angle. Got a 110 kilogram box, is pulled with a force F at an angle of 30 degrees from the horizontal and at an acceleration of 2.5 meters per second squared with a coefficient of friction 0.023. What is the force? So we're trying to find this force that's slightly downward. It's at 30 degrees. If you can see the picture on the left. First task is let's set up something. First of all, the acceleration is going to the right. The coefficient of friction, which is kinetic, is 0.023. Okay? And we should always start with the free body diagram. So start with the dot, looking here to the left. We have the force normal. Make the arrows about equal because the box is neither lifting up or going through the surface. So we have Fg. We have a force F, that's downward at 30 degrees theta. And the force of friction going back. Okay, so I like to tackle first the y component, the net force in the y direction. So our net force in the y is equal to Fn minus Fg. Whoops, there is a minus Fy. Let me show you what I mean. In the y direction downward, there's a component, Fy, for theta. Okay? So now we have this downward direction. If you look at the free body diagram, or if you want, I'll just move this over to the side here. So we got F, and we have a component that's downward, Fy. Okay, and that's theta. That's our opposite, therefore sine, if we were to look at it that way. Okay, you might probably be thinking, oh, is there one in the x direction? Yep, there's a component in the x that we'll call Fx. Okay, that's based on theta because that's the adjacent. Okay, so let's continue on. Since the object is not, the box is neither going through the floor or surface and not going upward, zero acceleration equals 0. So Fn equals Fg plus Fy. Let's break this down. This will be mg plus F sine theta. And that's what Fn is equal to. Fn, the normal force, is equal to these two components. Now, we can now tackle the x components. So the net force in the x direction will be negative friction plus Fx. And it is accelerating, so ma. Now, you need to memorize and know that the force friction is equal to mu kinetic times Fn. Okay, that's something that you need to memorize. So let's break this down. So minus mu kinetic equals Fn plus F cosine theta equals ma. Okay, well, we don't have our forces yet by themselves, so minus mu kinetic times, now we go to the left, we got Fn. Fn is mg plus F sine theta plus F cosine theta equals ma. We need to do a distribution. Mu kinetic has to be distributed, so let's do that. Minus mu kinetic mg plus, oops, this is going to be negative, so let's change that, minus mu kinetic F sine theta, okay, plus F cosine theta equals ma. All right, so now we have the force that's being applied in this downward direction. So let's get rid of mu mg and put it on the other side. So we're going to have minus mu k F sine theta plus F, cosine theta equals ma plus mu k mg. Okay, so I move that from the left to the right. Now, we can factor out the force. So we're going to have minus mu k sine theta plus cosine theta equals ma plus mu k mg. So let's put a parenthesis. We can move the quantity on the left and have the force all by itself. So let's get our equation set up. Notice that I did not put any values in. Move the variables around until you got it set up in the way that it's supposed to be so that you'll make less mistakes. Ma, mu k, mg. Actually, I could factor out the m here, and I'll do that with the values. Minus mu k sine theta plus cosine theta. Okay, I just moved the quantity over. So let's put some values in here. I'm going to factor out m. So put this out. 110 kilograms. The acceleration is 2.5 meters per second squared plus 0.023 times 9.80 meters per second squared. Let's close that quantity. Okay, and now on the bottom, 0.023, that's our coefficient of friction, sine 30 degrees. Okay, and that's a minus coefficient of friction times the sine 30 plus cosine 30 degrees. Okay, and this all equals 72.5 newtons, but we're only good to 2 sig figs, so 73 newtons is our answer. Box that up. Okay, so take this step by step. If you have a force pointing upward, just reverse the sign in the y direction for Fy and just apply the same math. Okay, review the video, slow it down if you need to. Happy physics-ing.